Alright, good morning calc friends, or maybe good afternoon if you're seeing this after noon. Our mission today is to solve exponential equation application problems. And the way I've structured the lesson is to do sample problems or example problems just like the ones you're going to have to do for homework. So for example, this first problem is similar to the ones that you see in 7 through 14 on your assignment that I'm going to give you today. And so we have A is going to be like that one, B, and I think there's a C on the next page. So I'm going to number the types of problems that are, or number the problems that are on your homework right here, and the problem that I have here for you in the notes is just like the problems that are here from your assignment. So without further ado, let's get started. So we're going to use the continuous interest formula to find missing quantities. So in your homework assignment, you're going to have a table, and you're going to have to fill in various parts of the table. So I've taken one line of the table and put the information here, and down here I've done a different line of the table and put some information, and then we're going to calculate that out. So our initial investment is going to be $3,000 at 2.5%. Remember, it's continuous, and I want to know how long it's going to take to double. And since we know that this is the continuous interest, we need to use the continuous interest compounded interest formula, which is A equals PE to the RT. And we know that we're going to double our $3,000, which of course makes $6,000. And so that's going to equal 3,000 e to the 0.025. Remember, we change our percents into decimals, 0.025 t. And then as before, in the last lesson, we want to isolate our exponential term. So we divide both sides by 3,000. And we get 2 equals e to the 0.025 t. And then in order to get rid of the e to the, and get the t down to our regular level where we like to be able to use our variables, we need to natural log both sides. So here we are, we've natural logged both sides. So we have the natural log of 2 equals 0.025 t. And then we go to our calculators, and we look up or calculate the natural log of 2, which is 0.693. Equals 0.025 t. Divide both sides by 0.025, and presto changeo, we have t equals 27.7 years in order to double our $3,000 and make it into $6,000. So this problem's already worked out because I'd already started this video and realized that I needed my calculator, so I went and got the calculator, and so now I'm going to restart with the calculator. So while I'm doing my calculations, you can do your calculations, and we can both practice together. All right, so that was the first line on the table. The second line, or maybe the third line, is going to look like this one. Find the amount after 10 years. So we have the same kind of situation here. We still have A equals PE to the RT. We still have $3,000 to start with. We still have 2.5%. So we're just going to plug in all that information again, and we want to find the amount after 10 years. So t is going to be 10. So we have A equals P, which is $3,000, e to the 0.025 times 10. I certainly don't need my calculator for that. So equals 3,000 times e to the 0.25. And then we go to find e to the 0.25, so I have second e, 0.25, enter. It'd be helpful if my calculator was on. So we have e to the 0.25, enter, which is 1.28, so equals 3,000 times 1.284 equals, so times 3,000, 123, equals $3,852.78. So that's going to be how much money we're going to have after 10 years. So these problems are pretty simple, just plugging in the numbers into the formula. Okay, same table, same formula, different numbers though, and different missing pieces. So we're going to start with $500, and we're going to go for, it says it'll take 8.5 years to double. Find the interest rate. It's the same thing, we use the same formula. So we start with A equals PE to the RT, And feel free, obviously, to pause the video anytime you need to so that people can catch up. And so we're going to double our money. So the principal is $500, and if we're going to double that, that means $1,000. So we have $1,000 here equals 500. E to the interest rate we don't know, so we'll put that as R. And the time is 8.5 years. So times 8.5. So as always, we need to, if we're going to solve for anything up here in the exponential area, we need to isolate the exponential term. So we're going to divide both sides by 500. So we'll get 2 equals e to the 8.5 r. And in order to get rid of the e, we need to natural log both sides, so we can bring the 8.5r down. So the natural log of 2, which we already have looked up here, which is 0.693. So I'm going to do that over here. So we end up with 0.693 equals 8.5r, because we got rid of the e there. And then we divide both sides by 8.5, so 0.693 divided by 8.5 equals 0.082. So R equals 0.082, or 8.2%. So pretty easy, just following the formula. And then using the same information, we want to find the amount after 10 years. Still using the formula. So I like writing the formula down when I'm teaching this stuff because it makes it easier for you to follow. P to the RT. So we're going to put in $500, and we don't know the amount. So we have $500, e to the r, which is amount after 10 years. So we found the interest rate is 8.2%, so we're going to have 0.082, and the time is 10 years. So we got 10 right there. So we're going to multiply 10 by 0.082, which is 0.82. So A equals 500 e to the 0.82. So we go over to the calculator, and we do second e to the 0.82 equals 2.27. And we're going to multiply that by 500. And we have $1,135.25. So that's how much money we're going to have after 10 years. All right, so those are problems like 7 through 14.